it's the last part, okay? The next after this time now, you have time to work in another things, okay? Again, it's this class about network is the less theoretical part of the course. The other part is a very small theory, and all the class you have labs to do, okay? I believe it's the hardest part of the course, okay? It's hardest because it's a little advanced, okay? And but the big problem is because the focus of the course is not network, and you don't have you don't apply this network, you don't use it, okay? You study but you don't use it, okay? But again, it's the last part, okay? The next hour we have things to do, okay? It's not only listen. For now, it's the last part. For now, you don't have a lot of theory class, okay? All the class is practical, okay? So what is a wireless sensor networks? The wireless sensor networks is a network of smart objects, okay? Is a wireless network, but only smart objects. The difference between the normal Wi-Fi to wireless sensor network is because these two things, two characteristics here, two attributes here. You have diverse devices. For example, in the same network, you can have a Google device, an Alexa device, and an iPhone. Okay, three different devices, three different providers, and the device needs to talk one to other. Okay. Another one is about heterogeneous. Heterogeneous means you have not only different devices, but different functions. Okay, for example, you can have a heart sensor, okay, a heart device that measure your heart condition, okay. In the same network, you have a smartphone, completely different functions, and you need to accommodate these different functions in the same network. And the last one is a source constraint. For example, my smartwatch don't have a lot of power. It has a smaller storage, very smaller storage device, and very few capacity to process things. And you have the smartphone that have a lot of storage and a lot of power. But in this type of network, most of the device is not like a smartphone, but it's like my smartwatch. Don't have a lot of power, don't have a lot of storage. You have a few research, and the protocol need to consider this. Need to consider that you don't have a lot of power to process messages. Not like, for example, a wireless environment that you have computers and smartphone. Okay. What type of limitation you have? The first one is limited process power. Again, a webcam don't have a lot of power. Alexa don't have a lot of power. Okay, limited memory. You don't have a lot of memory to store things. For example, if you need to, for example, to manipulate things in real time, you don't have power and don't have space to accommodate the information. It's a lost communication. Because you don't have a lot of power, the protocols, you don't have this type of application need to convive or need to survive if you don't have connections. For example, need to work most of the time in a synchronous way. The protocols that we studied in the GP need to implement using the asynchronous message. Do you know the difference between asynchronous and synchronous? Yes or no?
Asynchronous is where there's like no synchro, like synchronous is like at the same time. For example, right now we're having a synchronous session, and an asynchronous session would be like like you disconnect, but we do stuff or something like that. Like you leave us homework, like everything does, like everyone does their thing at their own time, at their own place, and all of that.
Exactly, exactly. It's the definition of asynchronous. This type of application, IoT application, need to sometimes is you have synchronous application, but most of the application is asynchronous because, for example, you have a sensor that send data to a device, but the network most of the time is not available. For example, satellite. You have a lot of IoT devices to measure things in a very remote place. You don't have satellite communication, satellite links all the time because the satellite flying around the Earth, okay? And sometimes the satellites illuminate one place, but the other place in other part of the globe is not illuminated. So this device needs to send the data when you are illuminated, but when you don't have links, need to keep the message, and when you have the link again, you send the message, okay? Limited transmission speed. This device don't have a lot of speed. My smartphone, sorry, my smartwatch don't have, for example, Wi-Fi. It's only Bluetooth, and Bluetooth is very limited speed. Unlimited power. For this case here, the battery is not so big like my laptop. Okay, it's the reason. This device needs to be designed to consume few powers to be possible to work for a long time with a very smaller battery. Any questions? Uh, Another behavior is the event drive. A lot of application is event drive. For example, uh, my air conditioner measure the temperature, but don't do nothing. Okay, think that you have a sensor that measure the temperature of a valve. Okay, but only when the temperature is bigger than one specific threshold or smaller than specific threshold, you do something or open the window, turn on the air conditioner. Okay, it's event drive. You need to happen one event to do something. Another type of pattern is the periodicity. You send data to a place or send commands to a place in the specific interval. Okay, each 10 seconds, each 1 minute, each 1 hour. Okay. When analyze the wireless sensor network, one important thing that you need to check is the range. Okay, the range is how does far the signal need to be propagated. For example, here you have Bluetooth. Bluetooth is very close, but if you need to go to another home, for example, think that you have another house here. If you need to communicate one home to other, you need a Wi-Fi. It's in the same city. You need WiMAX. Okay, it's the range. It's so distance in one signal can be propagated. Depending the range that you're looking for, you have different technology. For example, if you're looking for short range, okay, it's a very smaller distance, you can use the Bluetooth. The Bluetooth is a set of protocols, is a technology that you connect very device with a very small distance. Okay. If the distance is 10 to 100 meters, you can use a different technology. For example, you can use Wi-Fi, you can use the low-range WPN, like, for example, the Zigbee, 6LoWPAN. For example, in the past, Zigbee is very, you use a lot of Zigbee protocol inside the implementation of IoT. The Zigbee is very close to is very similar to the Bluetooth. However, implement a lot of nice features, like, for example, more modes of function, different types of topology, implement specific types of security behaviors that Bluetooth does not implement. But today, if you plan to use this type of technology, if you need, for example, today you need more security, security features. You can use the 6LoWPAN. That is a very nice. 6LoWPAN use a mesh technology, okay, and it's very. It's not so simplistic like ZB. It's more advanced. It has more features. Has more capacity, and you implement a mesh topology. Okay. It's the main difference than Wi-Fi. It has the same capacity than Wi-Fi, but Wi-Fi most of the time implement a star topology, and the 6LoWPAN most of the time implement a mesh topology. Okay. In the long range, you can use technology like, for example, 5G, 4G, or LTE. Okay, or Wi-Fi. Okay, there are types of Wi-Fi that you can use, for example, a biggest distance. Another example is the WiMAX. Okay, WiMAX you can use to long range, or you can use a different type of LPWA technology, lower power wide area. It's the specific protocol to IoT. For example, the 6FOX LoRa most of the time. In this type of network, most of the time, or use LTE in the past, or use 6FOX or LoRa. With the advance of the 5G, you replace the LTE to 5G. But not now, but in the future, in the short future, maybe in the next 2 or 3 years. Okay? Any questions? So based on the range, you need to define the technology that you plan to use. But it's not only the range. You have another important thing that you need to think, the frequency. You have two types of frequency, a licensed frequency and unlicensed band. What is unlicensed band? For example, Wi-Fi. Wi-Fi you can use in 2.4 gigahertz or 5 gigahertz. Okay, you don't need to buy this frequency. It's an open frequency. It's unlicensed frequency. Okay. What's good in the licensed frequency? In unlicensed frequency, you don't need to buy to use the frequency. It's free. It's no charge. But you have a problem because the unlicensed frequencies don't have any assurance to. You don't have any protection. For example, that you don't have interference. For things in this situation, you have a router, and your friend has another router, and you turn on the router one close to other. It's clear that one router interferes in the other router. Okay. If you use Wi-Fi, you cannot do nothing. Okay. If your friend, you can talk with you can talk with your friend and say, "Oh, turn off your router using my router." But if you don't know the other guy, you cannot do nothing. in 2000, I believe it's 2000, 2001, the IEEE start to use the Wi-Fi outside. You create antennas that you can use Wi-Fi to connect builds in a short place. Okay, for example, if you have an industrial plant and you want to connect the builds that you have in an industrial plant, okay, facility, and it starts to happen in a place. I live in a place that you have a lot of industry close one to other, and the people start to install this type of Wi-Fi technology. What happens then? One equipment start to interfere in another equipment, and the people asking to go to display to analyze the situation. And when I analyzed the spectrum, I saw that one equipment start to interfere in another and say, oh, you use Wi-Fi. You cannot do nothing. What you can do is to replace the Wi-Fi links and use the fiber to connect one build to other. Okay? It's the problem of the unlicensed band. The licensed band, you have another problem. You need to buy for the frequency. And when you buy for the frequency, the frequency is available to be, you can buy the frequency. I work in the smart grid project here in Brazil, and it's like here. Give me a second. Okay. I need to interconnect one city and use a wireless link. And you analyze, in that time, you analyze the LTE, Wi-Fi NOT, and the 6-force LoRa and the I analyzed too the 6-LoWPAN, okay? Because 6-LoWPAN, you can use 6-LoWPAN to long range because again, it works mesh. Once you can have a mesh network here, and one node can talk with another node, and you create a new mesh cell. Okay, you can use 6-LoWPAN in a long range too. It's not so common, but you can use. And you analyze LTE, LoRa, Sigfox, and 6-LoWPAN. And the definition of the companies is to use LTE. But LTE is like 4G. Okay, the LTE is a technology between the 5G and the 4G. Okay, and using the LTE, the problem is you need to buy to use the frequency. You cannot buy the equipment to use. You need to rent the frequency. You need to use a licensed frequency. And in Brazil, this frequency is only the telecommunication provider, like the cell phone company, like Claro, AT&T, has authorization to use this frequency. Okay, but the company don't want to buy for this company to have your network. Don't want to buy a network from a cell phone provider. The company want to have your only network. The solution is the China Huawei has one equipment that use LTE, but in no unlicensed frequency, and it's the decision that the company has. But again, it's not only you need to think about the range, but the frequency is another problem. The unlicensed frequency means that you don't have no guarantee or protections in the frequency. You can have interference. Okay. Examples of ISM frequency 2.4 and 5 in the Wi-Fi, the Bluetooth frequency, and the most of the the 6-LoWPAN and others frequencies that you have here. Did you understand the difference between the licensed and unlicensed frequency?
License are more secure, right?
Yes, license, you need to ask it to a place, or for example, you need to buy, for example, in Brazil, you need to go to the agents that control this frequency and say, oh, this frequency is available to use, I want to use. And the agents can say, oh, yes, it's available. And the cost, it costs, for example, $1,000 for a month, or is not available. You need to buy for the company, for example, the Claro has the right to use this frequency, for example, is the license frequency. You need to go to a place to ask it if you can use or not. Did you understand?
Yes, teacher.
And a license is like Wi-Fi. You buy the equipment and start to use. But again, like you said, it's not so resilient. It's not protected to interference. You can have interference. Okay. Power consumption. Another important problem is power consumption. For example, LTE. LTE is good because don't consume a lot of power. Okay, it's different. For example, the 4G. Okay, because 4G is designed to support big device like a smartphone, computers. Okay, the LTE was designed to support IoT. Okay, things about the consumption of the consumer of power. Okay, the power consumption is a very important concept to IoT, because IoT don't have big batteries. Okay, so constrained node networks is like, for example, low power and loss network, because it's a lot of IoT network don't have a lot of power. Okay, because using batteries, small batteries, and don't have the network has a lot of disconnections. So when you compare the technology, for example, local area network, low power wide area, and cellular network, traditional M2M, it's important. In the past, you have M2M network. What is an M2M network? Did you know this machine here? Give me a second. You know this machine? The machine is not an IoT device, okay? It's a device that you buy your credit card, you connect in the internet and see. It's a simple machine. It's not exactly an IoT, okay? In the past, it's not so past, okay? It's continuing to now. You don't have for example, LTE was designed to support this machine here, okay? You need you use these for example, LTE to connect thousands of this type of machine. Okay, so when you think about cellular networks like 4G, 3G, or LTE, you're looking for a network that connects, for example, this type of machine-to-machine device. Okay, when you start to think about Internet of Things, LoRa is much better technology. But again, you can use LTE too, okay? And finally, when you think about local area network, you can use Bluetooth, Wi-Fi, it's much better because it's a common protocol, it's cheaper protocol, okay? You have a lot of different devices, okay? But depending on the technology that you use, you can use a different type of technology. Okay, Guys, and the next class, we start to talk about IoT access technology. Okay, we'll discuss about Wi-Fi, about the 6LoWPAN, about LoRa, and NB IoT, that is 5G technology to IoT, or LTE, that is 4G technology to IoT. Okay, again, I didn't start this talk today. We use the time of the class next week because I think that you was contact with a lot of new things. If you already studied network, no, it's okay. You don't study nothing so hard. But I believe a lot of you is the first time that you have contact with network, bandwidth, and a lot of different concepts. Okay, it's the reason that I don't continue this talk today.